So the kinetic molecular theory is made up of 5 postulates that more or less explain many properties of gases. The first of these postulates is that gases are simply made of tiny particles whose size is negligible compared to the distance between them. So in this sample of gas, we've got several gas particles, but we are going to make the assumption under the kinetic molecular theory that the volume of the actual atoms is so small compared to the total volume of this box that the small volume of those atoms then is negligible. So essentially what this first postulate of the kinetic molecular theory is saying is that the gas particles have no volume. Now we know this isn't quite true, but it is true enough, especially for smaller particles, that we're able to safely make this assumption and still obtain proper data and calculations. So again, the first postulate simply says that the gas particles are so small that their volumes are negligible. The second postulate says that gas particles move randomly in straight lines in all directions and at various speeds. So in this box, we have 4 different gas particles, red, yellow, green, and a blue. And they're all moving in straight, random lines in all directions. But you should notice that the length of these lines is indicating the speed or the velocity of that particular molecule. So in this one moment in time, if you took a snapshot, it appears that this blue molecule is traveling slower than this yellow molecule. Now, you could take the average of all of these in order to find the average kinetic energy of them. So we could find the average kinetic energy, and that's something that'll be useful later. But for now, you simply must understand the second postulate is saying that even though items may have an average kinetic energy, that doesn't mean that they're all traveling at the same speed. As you can tell from here, the blue one is traveling slower than the yellow. The third postulate simply says that forces of attraction and repulsion in a gas are negligible except for when they collide. So if one gas were passing this direction and another gas were passing this direction, they're going to be pretty close together here. But we are safe to make the assumption under the kinetic molecular theory that even if there were to be some sort of attraction between these two particles, it won't be enough to do anything, so therefore that attraction or repulsion is negligible. Postulate 4 says that when gas particles do collide, it's considered an elastic collision, meaning no energy is lost. So what this means is if I have this red particle and it's heading in this direction, and a blue particle that's heading in this direction, if they collide, they are not going to lose any energy. They are simply going to transfer energy back to one another, and in the process, basically just ricochet off one another in the directions opposite which they came. So no energy is lost when gas particles collide. And we can kind of use like a logic scenario to think about why this is, or how this could be proven. If I have a sample of a gas in this closed container, these particles are moving in straight lines. They're going to collide with one another. If energy was lost during these collisions, eventually these gas particles would lose enough energy that they would not have enough energy to stay as a gas, and ultimately they would condense as a liquid. Now we know this isn't true because if you fill a balloon, you can come back days later and the balloon hasn't condensed into liquid breath. It is still your gas particles. So this means these collisions between these particles are perfectly elastic, meaning no energy is lost. Also, this postulate describes collisions with the walls of a container. So in this container, we have particles that are moving in all directions. When these particles collide with the wall of the container, they exert a force on that wall, and that force is measured as pressure. The pressure of a vessel is simply due to the force of the particles colliding with its walls. And last, postulate 5 Oh, look at me, I've misspelled average. I still misspelled it. Oh well. The average kinetic energy of a substance is proportional to its Kelvin temperature. So any calculations that you make need to use Kelvin temperatures. So if we were to think about the equation for kinetic energy, the kinetic energy of a substance equals 1/2 times its mass times its velocity squared. So if we were to want to increase the kinetic energy of something, of a particle, for example, well, we can either change the particle's mass or we can change the particle's velocity. Well, if I'm dealing with a particle of maybe diatomic hydrogen, I can't actually change that hydrogen's mass. Its mass is what it is. So I don't have the option to change mass. However, I could increase or decrease the velocity of a substance by changing the temperature. By changing this velocity, I am then mathematically changing the kinetic energy of it. Since a way to change the velocity of a substance is to, for example, increase the temperature, increasing the temperature would result in an increased velocity, which would result in an increased kinetic energy. So this kind of helps tie together how Kelvin temperature and kinetic energy are essentially the same thing. As one goes up, the other has to go up as well. And these are the 5 postulates of the kinetic molecular theory.